Let's move on to the part 2 of previous year's questions regarding GATE exam of the topic basics from the subject electric circuits. Okay. In part 1 we have discussed questions from the year 2019, 18 and one question from the year 2017. Now we shall be discussing the second question from the year 2017. Let's get started. The second question that was asked in the year 2017 is actually a circuit which is filled with resistances, and you have to calculate the equivalent resistance of this entire circuit. This question carried 1 marks and is actually easy, but you have to realize one small thing, that this entire line is actually 1 point. Okay, so if you place this resistance as here, okay, you just put this terminal of the 6 ohm resistance as in like this way, and the value and the resistance of 3 ohm as this way. So you get a parallel combination of two pairs of resistances. Okay, what I mean to say is you can turn this circuit into this particular format over here. Okay, when you switch the circuit, when you manipulate the circuit, you get two parallel combinations of circuits. Okay, now this question is easy to solve. These two happen to be series, and the resultant would be parallel to this, and the resultant would be parallel to this, and the entire thing would be in series with this, in parallel with this, and in parallel with this as well. And when you solve it, you get this circuit over here. Okay, this is your 1 ohm and this is your 0.8. Okay, apart from these two resistances, when you solve all these resistances, you find out the equivalent, you get as 1.2 ohm, and you get this series combination of 3 resistance, which would give you the equivalent resistance as 3 ohm. So this question was also easy. Then we have one question from the year 2016. Okay, in this particular question they have given you that the voltage and current sources are ideal, and you have to find out the output voltage of this particular circuit. Now we have this as your voltage, and you know that this and this together also, because the formula of we know the formula of Ohm's law. Okay, so this and this also give you some voltage. Okay, it is 10 volt plus 2 into 5, IR equals to V by the Ohm's law. So we have 5 into 2 plus 10, and the output voltage would be 10 plus 10, that would be 20 volt. This question also carried 1 mark and was easy. Now let's move on to the second question that was asked in the year 2016, but from another set. Okay, this was from set 1 and this was from set 2. Now what we are doing here is they are asking you what is the value of VA. Okay, this particular node voltage they are asking, and this question carries 1 mark. And since they are asking node voltage, it is a very clear indication that you have to apply nodal analysis. Okay, so you apply nodal analysis first this way, this way, this way, and then this way. Okay, you connect to the ground, then you write VA minus 0 upon 5, then you write minus 5, then you write VA plus 10, because you are getting a minus terminal first, so you write VA plus 10I upon 5 ohm, and then you write as VA minus 10 upon 10 ohm. Okay, so this is your required nodal equation. On solving this, you get the value of VA as 80/7 or 11.42 volts. So this question was also easy. Now we are having another question, which is what is the current supplied by this battery. So this question over here carries 1 mark and is also from another set. Okay, in 2016 they had 2 sets. In one set they asked this question, and in the next set they asked 2 questions. Okay, so this question is actually regarding super mesh, which I will explain on paper in the next video. Okay, so stay tuned.